It's entitled Secure Persistent Key Value Store. So before we go into the secure version, let's remind ourselves about config maps, which is essentially a unsecure key value store. And let's look at the example here. I'm going to look at two examples. One is essentially, I don't know if we've done much of this, is it using config maps to work with pods on setting some environment variables. And then we'll do, again, a separate, same pattern, but just with a volume. That is actually, config maps actually will create files and that are exposed to the containers. So let's first look at the environment example. And of course, I don't have myself in the right folder. So let me go there. And I'm in, this is probably config maps is 28. Okay, so the first example we want to look at is the environment, config map environment. And obviously I have this way too small. Okay, so let me go to the template. So the config map itself, we've seen this already early on, right? It's just basically, it's a key value pair. A maps to A, B maps to banana. Nothing fancy there, nothing new. Here's where we do something a little different from what we, so here's a pod, right? And down here, just in Ubuntu, and I'm not restarting it because I just want to have it run, right? And if you look right here, this is the key. I'm setting an environment variable called A, right? So there's an environment variable inside the container named A. And the value is coming from a config map that I'm referencing and the key in that config map. So essentially A in the config map is mapping to an environment variable A in the container. Okay, pretty clear. And you can see my command here, I'm basically calling bin shell. And I'm echoing out, basically this is a way in Linux to reference an environment variable. So I'm echoing hello, whatever the value of A is, which I believe is Apple. Now, just one side note, to use environment variables within a command, you actually have to do this pattern where you have to call some command and pass it. Like for example, if I had just tried to do echo hello $A, right here, like the first was echo, and then the second parameter was hello $A, it wouldn't work because in that case the parameters are not being interpreted by the shell, right? And then the shell is where these variables get reassigned to their environment variables. So this was a way around it. By calling shell and then running this command, I'm causing the shell to interpret $A. So that was just a quick thing I learned, that you just can't echo hello A without using the shell because the shell never interprets the environment variable. Now your code itself internally could be using environment variables, and that's fine, in which case you wouldn't have to do this rigmarole with calling bin shell. This was just because I needed it to happen on the command line. Okay, hopefully that made sense. Let's just go ahead and run this. I mean, nothing terribly spectacular here. Helm, install dev, config, map, environment, and it should run. Let's see, control get all. I should see a terminated container, right? And then I go to controller log example dev, and it should say hello Apple. Okay, nothing unsurprising here. Helm uninstall dev. Okay, let's go on to the next example. The next example is just how do we use them as volumes. So I go here to volume, templates, same exact config map. And here though, I'm creating a volume, and it's creating a volume based on a config map, right? So there's the config map. I reference a config map, right? And I'm basically calling this volume config. And you can see now that this volume is being referenced by my container. I'm mapping it to etc config, okay? And then Here, just to quickly illustrate it, it will create a file, right? This case, I'm actually going to create files in this folder, right? Etc. config. There'll be a capital A, right, that references Apple, and B references banana. And all I'm doing, just to illustrate this, I'm just LSing the config folder, right? So let's run this one and see what happens. Helm install dev. I already forgot what this is. Config map. Helm install dev config map volume. Okay, so kube control get all should be done, and I should be able to log it. Log example dev, and I think I should see, so the listing of that configs folder is there's two files, A and B. I'm not showing the content of them, but they're Apple and banana in those files. Okay, helm uninstall dev. Okay. That's config map. Okay, so now let's move on to secrets, which is really the point of this section. And first of all, they're very similar in many respects to a config map, right? They store key value pairs, right? They're both of them are namespaced, so that there's similarities there. And there's one difference though, what we'll get after here. So let's look at the example here first and see how similar they really are. And then we will then see where their differences are from the config map example. So you can see, for example, from config map volume, the config map looks like it's a config map, and it has data A and B, right? Let's look at the example secret environment, right? Templates, example pod. Right? I want to look at the config map itself. So so it's a secret, but instead of data, it says string data, okay? And the reason that's one difference. And the one difference we're going to get to is, so the big difference between secrets and config maps is ultimately when secrets are stored in Kubernetes, they're stored to be stored as base64 encoded strings. They're not really encrypted, right? They're just encoded so that if they happen to pop on the screen, for whatever reason, then the human can't read it and see what it is. So it's just kind of an obscured value of the string. And so if I provided just data here for reference, then the expectation is that what you're supplying as the values, not the keys, but the values, are actually already base64 encoded. By providing string data, you're telling it that you're actually providing the raw strings, and then behind the scenes, Kubernetes, when it actually creates the secret, it will actually base64 these strings for you. So that's the one difference, is that string data is what you use here because you don't want to have to say base64 this yourself. Now, as a practice, by the way, you probably wouldn't be. This is a config file that, in theory, you're committing to into your source control. You probably wouldn't be creating files like this. You might be creating secrets, or you may create it separately. But you wouldn't be including the secrets in your along with your pod definitions and whatnot, like I did here. I just did in this example. You really need to treat these as separate. Okay, so that's a side note. Let's go ahead. The pod, I guess, let's look at the example here. Here I'm basically have the same kind of command, right? I'm creating an environment variable, and instead of a config map ref, I'm just calling a secret ref. So it's pretty much exactly the same pattern, okay? And we'll notice that when the secret gets pulled in, even though the secret's stored as base64 encoded, when it gets exposed to the environment, it gets automatically decoded back into its raw form. So let's do this. Let's run this and then poke around a little bit. So I'm going to do helm install dev secret environment. So let's first just make sure the container ran, see its output, and then we'll poke around. So helm. So the container should have run. Let's log it. Should be exactly the same example as should see very similar to the config map, right? Now let's look at one difference here. Control describe secret. Where was it? Secret. Get secret. So describe secret example dev. Okay, so right. Okay, I panicked for a minute there. So right. So the key here is, if you look at the data here, instead of if this was a config map, I would see the word Apple here. But instead, I just say, hey, there's just some amount of data, and it's being hidden. Right? I don't see the actual data when I look at it. But when it got used, it basically decoded it. If I actually was to get the secret, let's see if I can get this to work. So get secret example dev o YAML. Where's the value of it? Oh, right. Here's the data here. So if you look at the data here, I don't see apple and banana. I see these, right? And then to illustrate this, if I copy this, just to show that this really is just base 64 encoded, if I do echo paste base 64 decode, and there's my apple right there. So these are just base 64. They're not really encrypted. They're just obscured. Okay, let's see if I missed anything. So we decoded the secret, right? So one thing I did want to notice here, when I looked at the details of this one, let's see if it was at here. See this opaque here? So by default, when you create a secret, the default value is opaque, and there's not really great documentation on what the other possible values are. I think we can see some here. Here, I'll show you another example. So there's another one here called default token, right? And you notice that the type here is something else, Kubernetes IO service account token, right? So the question is, well, what does it mean to be a different type? If I describe this one, so describe secret default token, right? It basically looks very similar, right? There's nothing except for it has some different keys, but otherwise, other than the type being different, everything else looks essentially the same. Now, it turns out the type is just a validation mechanism. So the best I got was actually a link that went to the source code that talks about the different types. And you can see that by their own description in the source code, opaque is basically, let's see if it says here. Actually, it doesn't. Wait, see, hang on. They don't really describe opaque, but you'll see, here's the key here. If I look at, for example, they're describing, oh, here it is. I know I see it. Secret type opaque is default arbitrary user defined data. But the service account one, which is the one we just saw, right? It looks like this, service account token, right? They're basically saying, oh, these are required, right, to have a number of fields. And they're saying it needs to have, in the data, it's required to have a token, right? And if I look at the actual, and there's my token, right? So this is basically by declaring a different type, and what happens is when you're submitting this, I'm guessing this code actually runs here and validates, if you call it a token, there's some validation rules that require certain keys, essentially. So that's the purpose of the type, is to do a validation step when you create these objects. Okay, enough about that. Let's see. Okay, so that's the types. Okay, let's go ahead and look at the secret volume, right? It should be not a lot of surprises here. So let's look at the code for secret volume. Template. Okay, the secret itself is the same, but the volume, okay, so in this example, the volume, you're referencing a secret, right? and then you are referencing a secret. You're mounting it to etc. config, so that's pretty much expected. Excuse me. Now I made the command a little longer here because I'm actually doing a little bit more here because I'm going to illustrate something in a second. But if you look at this is basically, this container will never go away, right? Never restarts. It has a default of restart never, or restart policy of never. So this will always stay open or run. It's looping, right? I'm sorry, this doesn't have a restart never. This has excuse me. Okay, this actually has a restart policy of it's not never, it's a default, which is basically keep it up and running. I have to remember what this is again. I'm spacing out, but long story short, this container will keep on running, and it's looping, and all it's doing is catting out the value of the secret A, and then waiting a second and repeating. Okay, so let's just first run this, and then I'll explain why I'm doing the loop in a minute. And let me pause for a second. I'm going to go get some water. Let's go ahead and let's run this example. So helm install dev secret volume. Oh, apparently I forgot to uninstall the other one. Okay, let's try this again. Okay, so we see it's running. Cube control, scribe, pod. Bear with me. I'm looking up the policy. The restart policy is called. Where the hell is this thing? Okay, hang on a second. I want to look up that restart policy. I don't see it here. It must be here. I just don't see it. Okay, I know what I'm gonna do. I'm just gonna get it. I'm gonna output its full YAML. Grep restart. Okay, it's always. I was obsessing about what the restart policy default was. It's always, right? Before we were using never. Okay, so if I do kube control logs, and then this is on example dev. Okay, so I got Apple. Okay, I'm going to continuously run this. Right, that's the Apple. Now, reason why I'm doing this is that it's just cycling on Apple, right? What I wanted to do here is get to the last point of this. One of the things that, right, so right now that secret is in a file, right, and it always has A in it, or it has the word Apple in it. Now, one interesting thing is if you change the secret itself over, like maybe about a minute later, the file inside your pod actually will change. So there's a process where we'll actually go in there and change that file. And that allows you to change out secrets, because secrets oftentimes are rotated, like tokens have an expiration, and you need to rotate them, and you don't necessarily want to kill your pods whenever a secret changes. So this is only relevant for secrets, and it's only relevant for changing files. The environment variables are what they are. They're not going to change on you, but the files will. So we can illustrate this by, see if I can get this to work. I need to go into, what I'm going to do is I'm going to go into my secret volume, right? And I'm going to go into my secret itself, and it says Apple here. I'm going to change this to apricot. So I save that. So the file's changed in my here. Now I haven't deployed it, so I have to now go to Documents, K8SCKA tutorial. This is under 28. Okay, so if I do helm upgrade dev secret volume, that should change out the secret. right? So for now, if I was to do kube control, so first of all, it still says Apple, right? But I'm going to watch. I'm just going to observe here. I'm just look at the secret and make sure the secret really did change. So get secret. So what is it? I want to do get secret example dev YAML. All right, all I'm doing right now is inspecting it. I'm curious to see how long this also changes. It takes. Oh, there it is. I see apricot now. Okay, well, I mean, I guess you should believe that it changed, because you see now, if you look here, in about 30 to 40 seconds, that container now shows apricot as the value of A. And if I was to go into the secret itself, you would see it's changed too, right? So that was the whole point of this, is know that changing secrets will eventually change the value of the file that is in your container. Okay, so let's kill this. I think that's all I really want to illustrate there. Make this bigger. Okay, so what else was I going to cover? Okay, so just a couple of other things about secrets, right? In the docs, let me go into secrets here. There's a whole section about precautions that are made around secrets. So it's the very bottom. And I'm not going to try to read them all off, but config maps are kind of wide open, but there are some precautions, if I can find it. Blah, 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 use cases. Of course, now I can't find it. It's at the very bottom of this. Oh, here it is right here. So there's a whole section called security properties, and there's quite a bit of discussion around things that Kubernetes does to try to limit the secret, right? For example, the big one here, obviously, that a secret's only available to the node that requires it, right? So it's basically not written to disk. So if kubelet, if some other container was to try to read the disk of kubelet, it couldn't find that secret, right? So that's this is basically an in-memory storage, basically, not written to disk. So that's one example, but there are other examples here. Now, one thing that's interesting, though, that I find it strange, is that this secret is still just base 64 encoded. It's not really encrypted at all. So, in between, that's still a memory now on kubelet, kind of in open form. It's just opaque. It's not really encrypted, right? So it feels like there should be more of an end-to-end encryption strategy. And it turns out that AWS, and I didn't go through all the details of it, but they actually, literally, this is March 2020, so that was just like a couple months ago. They announced that you can use, Amazon has something called KMS, Key Management System, and you can actually do encryption. Basically, you can encrypt data, essentially. And apparently they have a mechanism now where you can do more of an end-to-end encryption strategy for these secrets, so that in between, you're actually storing encrypted, not just encoded. Okay, so that's outside the scope of this video, and I didn't actually go through the exercise of doing it, although there's instructions on how to use it. Okay, so that is the entirety of this video. Thank you.